So for this chapter, we have 7 properties that we need to know. The first one, if our function is a constant function. For example, limit c x approaching a, we will get the answer as the constant itself. Second, if we have limit x as x approaching a, the answer is gonna be the limit itself a. We have a power function, limit x power of n. The answer gonna be a to the power of the function. Second, if we have a constant in front of the function, we just gonna put the constant in front and then direct substitute the limit into the function, and we're gonna get the answer. And for addition, subtraction, division, and multiplication, it's just the same, where we're gonna separate the two functions and then direct substitute the limits, and we're gonna get the answer.
So there are several methods to solve the limits. So there are 8 methods to solve the limits, which is method 1, direct substitution, method 2, factorization, method 3, conjugate, method 4, to find one-sided limit, method 5, to determine whether the limit exists or not, and method 6, to find the vertical asymptote, method 7, to find the horizontal asymptote, and method 8 is problem when infinity divided by infinity.
Method 1 and method 2. Let's look at this example. We have limit x approach to 4, x minus 4 over x squared minus 16. So when we direct substitute the x value, we will get 0 over 0. So we have to use the method number 2, which is factorization. When we do factorization, we can cancel out the factor that makes the limit 0 over 0, which is x minus 4. Then we will get limit x approach to 4, 1 over x plus 4. We can just write the 1 because it is properties 1. And x plus 4, we use method number 1, which is direct substitution. And we will get the answer is 1 over 8. Method number 3 is when there is set in the limit. For this example, we have limit x approach to 2, x minus 2 over set x plus 2 minus 2. If we just simply put the x value, we also will get 0 over 0. So that is why we need to use the method number 3, which is multiply with conjugate. When we multiply with conjugate, we need to expand the denominator. So we will get limit x approach to 2, x minus 2, set x plus 2 over x plus 2 minus 4. Then we can cancel out the x minus 2, and we will get limit x approach to 2, set x plus 2 plus 2. And we can apply the method number 1, which is direct substitution, and we will get the answer is 4. Next is method 4, which is to find one-sided limit that have modulus. For this example, we have limit x approach to negative 2 from left. So to solve this type of equation, we need to using the definition of absolute value. We know that the limit approach to x approach to negative 2 from left. So we have to choose the x less than 2. So we will put the negative sign in front of the x plus 2. So we can cancel out the x plus 2 from the top and at the bottom. So we will get limit x approach to negative 2 from left x plus 3, negative 1. And we will get the answer negative 1.
So next, we will use method 5 in this kind of question, which is given the function as fx equals to x squared, fx equals to 1 plus 2x, fx equals to set x. So the question asks to determine the limits at x equals to 2 if it is exists. So we will apply method 5, which is step 1. We will find the x equals to 2 when it is approach x from left side. So we will substitute the 2 into the x. So 2 squared is equals to 4. Second step, we will find x equals to 2 from right side, which is the function is 1 plus 2x. So 1 plus 2, substitute the 2, then we will gain 5 for the answer. So step 3, we will determine if the answer is left side. and is not equals to limit fx when x approach to from right side. So therefore, limit fx when x approach to 2 does not exist. So next, given the question, which is the function kx goes to 1 plus x over x minus 3. So the question asks to find limit k when x approach 3 from the right and x approach 3 from the left. So we will apply the method 6 in this kind of question. So we use the method 1, which is direct substitution. We substitute the 3 into the function. So 1 plus x, which is 1 plus 3, equals to 4, and x minus 3, which is 3 minus 3, equals to 0. So when the x approach the 3 from the right side, so we can assume that the number is 3.1, where you can look at the number line where the 3 from the right is. So when we substitute the 3, which is 3.1, where we assume the number is 3.1, since the number is 3 positive, when x approach 3 from the right, so 3.1 we substitute into the x. So 3.1 minus 3 equals to 0 positive. We put it on the right, on the top of the right. So it is when 4 over 0 positive, we will can plus infinity. Where we will be using the same when limited x approach 3 from the left is 1 plus x over x minus 3. So we will assume the x is 2.9, which is from the left, below 3, number 3. So 2.9 minus 3 is negative. So 0, we will get the 0 negative. So 4 over 0 negative is equals to negative infinity. Next, given the function as stated, so the question asks to find limit gx when x approach to negative infinity and positive infinity. So we'll apply method 7. So this is the solution. So limit 3 plus 1 over x squared when x approach to negative infinity. So we will apply the properties. We will apply the properties of limit where we will separate the 3 and 1 over x squared. So the 3 will remain 3. Limit 3 when x approach to negative infinity will remain 3 as properties number 1. So plus limit 1 over x squared when x approach to negative infinity, we will get 0. So and everything that divided by infinity will get 0 as method 7 stated. So just like limit gx when x approach to positive infinity, we will do the same thing. So we will get the same answer. Next, for method 8, when limit as stated when x approach positive infinity. So this is the solution. So we will apply method 8. So we will do the factorization so that we can cancel out the x. So x will be cancelled out. So we left with set 1 plus 0 over 1 minus 0. So this question will left us with 1. So next, I will explain about asymptotes. So asymptotes, we have two kind of asymptotes, which is vertical asymptote and horizontal asymptote. So this is the question, example for vertical asymptote where fx equals to x plus 3 over x plus 2. Step 1, we will use the denominator as our vertical asymptote where x plus 2 equals to 0. So we will move the 2 to the right side. So we will get x equals to negative 2. So step number 2 is we will use the x equals to negative 2 as our substitute. So limit fx when x approach to negative 2 from the left side is negative infinity, where negative 2 we will be substitute that negative 2 into the function. So negative 2 plus 3 over negative 2 plus 2. So we will get 1 over 0, 1 over 0, negative. We will apply the method number 6. So limit x when limit fx when x approaches to -2 from the right hand side also like this, also same, just like the limit x when x approaches negative from left side. It is just the same. So we have the answer is -infinity and positive infinity. So step 3, we will state the answer, which is x equals to -2 is a vertical asymptote for fx. Next, horizontal asymptote, where we will be applying method 8. So given the question where fx equals to x over x -2. So this is the solution, the limit fx when x approaches to positive infinity, where we will applying the factorization. So we will cancel out the x at the numerator with the x at denominator. So we left with 1 over 1, 2 per x. So we will substitute the positive infinity. So we will get 1 over 1 minus 0. So we will get 1 for the limit function fx when x approaches to positive infinity. So just like that, we will use the same thing to the limit fx when x approaches to negative infinity. So we will get 1 as the answer for this question. So horizontal asymptote for this answer is 1.
Continuity. What is continuity? Continuity is when the function y equal to fx is continuous if first fc is defined, second is limit x approach to c fx exists, 3 is limit x approach to c fx equal to fc. When the limit x approach to c fx equal to fc, it is two-sided continuity. When the limit x approach to b from left fx equal to fb, it was continuity from the left. And when it is limit x approach to a from right fx equal to fa, it was continuity from the right. Continuity. Let's look at this example where we need to determine whether the function f is continuous at x equal to 1 and x equal to -5. First, we have to do the number line so that it will be easier for us to see the function from left and from right side. First, x equal to 1, we need to do the 3 steps. First is when x equal to 1, we need to put the x value at the function, so we'll get 3. Step 2 is we need to find the limit x approach to 1 from left and from right. We can look that at the right and left side, it is equal to 3. So we can conclude that limit x approach to 1 fx equal to 3. Step 3 is we need to f equal to 1 equal to limit x approach to 1 fx. So we can conclude that fx is continuous at x equal to 1. For x equal to -5, we just do the first step. When x equal to -5, we put the x value. It is undefined because the function, there is no function at the left side. So we can conclude that fx is not continuous at x equal to -5.